Blackcircles.com. Tyres locally for less. Worn or damaged tyres can have a significant impact on safety by reducing the acceleration, braking and handling performance of your vehicle. Driving on illegal tyres can not only invalidate your insurance, but also result in penalties of up to £2,500 and 3 penalty points per tyre. Flat spotting occurs when the tyre locks up under heavy braking, such as an emergency stop. When driving, objects such as stones and nails can get embedded in the tread. This can lead to a puncture in the tyre or can cause the tyre to rupture. Cracking or crazing of the tyre can occur through degradation in the tyre due to low usage and old age. This can also be affected by some climatic conditions. Impact with the curbside or a pothole can cause scuffing to the side wall of the tyre. In worst cases, and especially with underinflated tyres, the tyre can separate from the sidewall, leading to bulges or air pockets in the tyre. Tyres with bulges and air pockets in the sidewall should be replaced immediately, as there could be risk of a tyre blowout. At Blackcircles.com, we recommend that you check your tyres every couple of weeks and before any long journey. The Tyre Industry Council has devised a 5-point tyre check. Check the overall condition of your tyres, including inner and outer sidewalls. Check the tyre tread depth. Check all tyre pressures. Check signs of irregular wear, i.e. alignment. Check and examine the spare tyre. Blackcircles.com. Tyres locally for less. Blackcircles.com. Tyres locally for less. What does tyre tread depth mean? The majority of new tyres have a tread depth of 8 or 9 millimeters, and over time the tread is worn down and the efficiency of the tyre is reduced. In the UK, it is illegal to allow your tyres to descend to a tread depth lower than that of 1.6 millimeters. This limit applies across 75% of the tyre's width and all the way round the tyre. To help you monitor your tyre's tread depth, tyres are manufactured with the tread wear indicator in the grooves of the tyre. How to check tyre tread depth. In addition to the tread wear indicator, there are a number of different ways to check your tread depth. These are tyre gauges, which which give you an accurate and clear indication of your tyre's tread depth. However, a 10p coin can also be used. The distance from the coin's edge to the raised dots is 1.6mm, as highlighted. Put the coin inside the tread. If you cannot see the raised dots on the coin, your tread depth is within the legal limit. How tread depth affects stopping distances. Although the legal limit in the UK is 1.6mm, new research by the Motor Industry Research Association has shown that worn tyres have a greater impact on accidents than originally thought. Results showed significant increases in a car's stopping distance when tyres are left to their legal limit of 1.6mm, taking an extra 8 metres, nearly a bus length, to stop at 50 miles an hour. Blackcircles.com. Tyres locally for less.
A tire is round and it is black. However, if you examined all the manufacturing stages, you would realize what a complex product lies beneath its plain exterior. In actual fact, leaving the natural and synthetic rubbers aside, more than 200 different materials are combined to manufacture the tire that we know so well. There is carbon black, silica, and sulfur, plasticizers, vulcanizing agents. But there are also cords, a lot of cords, which in fact can be either steel or fabric such as polyester and Kevlar. These different raw materials are used to produce a wide variety of components. Flat or profile products, steel cord or fabric plies, and also bead wire. These components give the tire its elastic properties, ensure its resistance to wear, provide adhesion, and determine its service life. It all begins in the tire building drum, which is a rotating cylinder with a flexible center so that its edges can be brought closer to each other. You'll see why in a minute. A thin, perfectly airtight sheet of synthetic rubber must first be laid down on the drum. This will act as an inner tube inside the finished tire. The second layer is called the casing ply. Why? Because it contains the framework of parallel fabric cord, which we call the casing. This assembly is the vital substructure and consequently a key component in the radial tire. Set tightly against strips of profiled rubber are two high-resistant steel wire hoops, which are known as the bead wires. They hold the tire firmly on its rim. The casing ply is then folded up over the bead wires to hold them securely in place. Other components are added with the same degree of accuracy. Some tires have dozens of them. But don't worry, we'll not describe them all in detail. However, take a look at the sidewalls. They are made of rubber, both flexible and tough, to protect the tire from side impact. Then, by inflating the central part of the drum, its edges are brought closer to each other. The tire is shaped. The reinforcing tread plies providing directional stability and mechanical resistance have yet to be added. Fine but highly resistant steel cord strengthens these plies. Being laid crosswise to the casing ply, it forms shape-retaining triangles. Now it's time to lay down the tread rubber. It is this part of the tire which will have a tread pattern and will be in contact with the road surface. The unfinished tire is then put into the curing mold, which has all the tire markings and the tread pattern. A curing bladder filled with hot pressurized water forces the rubber back into the mold cavities. The hot water and steam around the mold start the curing process. This curing, or vulcanization, chemically bonds the rubber compounds to the steel and fabric cord reinforcement components. During this chemical reaction, the tire goes from a plastic to an elastic state. Sometime later, the transformation is complete and the tire emerges from its metal shell. The tire has been given its final features and finished shape.
Michelin, a better way forward.
A tyre is a complex assembly of many elements, implementing a wide variety of raw materials. The composition of the rubber compounds varies within a single tyre. Each compound is carefully developed to meet the requirements in terms of flexibility, resistance, grip, etc. Long lengths of metal and synthetic cable are also used. Manufacture is performed on the drum, a rotating cylinder whose central flexible section can be inflated for reasons which we will see later. The first element applied to the drum is a sheet of airtight synthetic rubber. This layer replaces the inner tube in today's tyres. In a second stage, a ply made of textile cords, sheathed in rubber, is then added. This network of cables will form a reinforcement radiating around the tyre. It is the radial carcass. Braced against strips of profiled rubber, two high-resistance metal cable hoops are installed. These are the bead wires. They will hold the tyre on the rim. The casing ply is folded over the beads to anchor it. Other elements are added. The sidewalls made of flexible, resistant rubber will protect the tyre from lateral damage. The tyre is then shaped by inflating the central section of the drum. Two plies are applied to the crown of the tyre. They are reinforced with metal wire arranged obliquely and, with the casing ply, form a network of triangles to limit the deformations of the tyre. Finally, the tread is fitted, the part of the tyre in contact with the ground. The tyre blank can then be installed in the curing mould. In the center, a bladder filled with pressurized hot water pushes the still malleable material to the base of the patterns engraved in the mold. The heat of the water and steam surrounding the mold will cause curing to begin. The rise in temperature causes vulcanization of the rubber. The sulfur incorporated into the rubber compounds forms bonds between the polymer chains. At this point, the rubber switches from a plastic state to an elastic state. When removed from the mold, the tyre has acquired its definitive form and properties.